The next concept is the difference between the interference and diffraction. We have seen the two phenomena, that is the one is the interference and another is the diffraction. So interference ಅಂದ್ರೆ ಏನಾಗುತ್ತೆ, so the two waves is combined together and the distribution of the what intensity has to takes place. ಎರಡು two waves ಸೂಪರ್ ಇಂಪೋಸ್ ಆಗಿ ಇಂಟೆನ್ಸಿಟಿ ಅಂತೂ ಡಿಸ್ಟ್ರಿಬ್ಯೂಟ್ ಆಯಿತು. ಸೊ ಇನ್ ಕೇಸ್ ಆಫ್ ದ ಡಿಫ್ರಾಕ್ಷನ್ ವಾಟ್ ಹ್ಯಾಪನ್ಸ್, so the bending of the light around the corners of the small obstacle. In diffractionally light illi corners hatra bend ಆಯ್ತು, so that we call as the phenomenon of diffraction. Interference means what? So modification of the intensity of the light. Intensity ಏನಾಯಿತು, modification ಆಯಿತು. So energy of the two or more waves that has to be what redistributed due to because of the superposition of the waves. So that is the first difference between interference and diffraction. Okay, so in case of the interference, the result of the superposition of the secondary waves originating from the two coherent sources. ಇಲ್ಲಿ ಎರಡು ಕೋರೆಂಟ್ ಸೋರ್ಸ್ನ ತೊಗೊಂಡಿದ್ವಿ, S1 S2. ಅದರಿಂದ ಬರ್ತಕ್ಕಂಥ ವೇವ್ಸ್ ಸೂಪರ್ ಇಂಪೋಸ್ ಆಗಿ ನಮಗೆ ಏನು ಸಿಕ್ತು, ರಿಸಲ್ಟಿಂಗ್. Okay, so we get the resulting superposition of the waves. Finally we get the resultant in case of the what interference. Other diffraction only single source, only the source is ಅದರಿಂದ ಬರ್ತಕ್ಕಂಥ ವೇವ್ಸ್ ಏನಾಯಿತು, ಸೊ ಸೂಪರ್ಪೋಸ್ ಆಗಿ again we get the what a single a part of the coherent source. ಸೊ ಒಂದು ಎಸ್ ಸೋರ್ಸ್ ಎಸ್ ಇದ್ದ ಬರ್ತಕ್ಕಂಥ ವೇವ್ಸ್. ಸೊ ಅಗೇನ್ ಇಟ್ ಈಸ್ ಡಿವೈಡೆಡ್ ಫಾರ್ದರ್ ಸ್ಮಾಲ್ ಪಾರ್ಟ್ಸ್ ಆಫ್ ದ ಸೋರ್ಸಸ್. ಆದರೆ ಇಲ್ಲಿ ಸಿಂಗಲ್ ಸೋರ್ಸ್, ಇಲ್ಲಿ ಡಬಲ್ ಸೋರ್ಸ್. ಸೊ here also it forms the what a diffraction pattern, here it forms the interference pattern. So diffraction is due to because of the secondary waves originating from the source. Again see, ಇಲ್ಲಿ ಸೋರ್ಸ್ ಇಂದ ಬರ್ತಕ್ಕಂಥ ವೇವ್ಸ್, ಇದರಲ್ಲಿ ಏನಾಯಿತು, ಜಸ್ಟ್ ಯು ಟೇಕನ್ ದ ಡಿಫ್ರೆಂಟ್ ಪಾಯಿಂಟ್ಸ್ ವೇವ್ ಫ್ರಂಟ್ originating from the source S1. So those we know that for every a point on the wave front it acts as the secondary disturbance ಅಂತ ಹೇಳಿದ್ವಿ. ಸೊ ಹಾಗಾಗಿ ಸೊ ಅದರಿಂದ ಬರ್ತಕ್ಕಂಥ ವೇವ್ಸ್ ಸೂಪರ್ ಇಂಪೋಸ್ ಆಗಿ, ಸೊ ವಿ ಗೆಟ್ ದ ಫೈನಲ್ ರಿಸಲ್ಟ್. So that is the second difference between the interference and diffraction. Okay, in case of the interference fringes ನಮಗೆ ಪ್ಯಾಟರ್ನ್ ಏನು ಸಿಕ್ತು, ಸೊ those are all having the equal width. ಸೊ ನಮಗೆ ಸಿಗ್ತಕ್ಕಂಥ ಅಲ್ಲಿ ಏನು ವಿಡ್ತ್ ಇತ್ತು, ಫ್ರಿಂಜ್ ವಿಡ್ತ್. ಸೊ those are all what equal width. ಸಿ ಇಲ್ಲಿ ತಲೆಗೆ ಎಷ್ಟಿದೆಯೋ ಡಿಸ್ಟೆನ್ಸ್ ಅಗೇನ್, ಸೊ ದಿಸ್ ಇಸ್ ಡಿಸ್ಟೆನ್ಸ್ is also what same. Again this distance is also what same. So whatever the fringe width is that is same. So we can say the interference fringes are equal width for monochromatic source. ಅಂದ್ರೆ monochromatic source ಅಂದ್ರೆ single colored source ಅನ್ನು ತಗೊಂಡಾಗ, ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ಇಫ್ ಯು ಟೇಕ್ ದ ವೈಟ್ ಲೈಟ್, ನೀವೇನಾದರೂ ವೈಟ್ ಲೈಟನ್ನು ತೊಗೊಂಡ್ರೆ ನಮಗೆ ಇಲ್ಲಿ ಈಕ್ವಲ್ ಸಿಗಲ್ಲ. ಸೊ ಮಧ್ಯ ಏನಿರುತ್ತೆ ಮೀನ್ಸ್ ಸೆಂಟರ್ ಏನಿರುತ್ತೆ ಬ್ರೈಟ್ ಇರುತ್ತೆ, ಮೀನ್ಸ್ ವಾಟ್ ಎವರ್ ದ ವಿಡ್ತ್ ಈಸ್ ದೇರ್ ಇಟ್ ಈಸ್ having a certain fringe width and remaining it has to be goes and decreases on either side to decrease ಆಗ್ತಾ ಹೋಗುತ್ತೆ ವಿಡ್ತ್ ಯಾವುದರಲ್ಲಿ, ಇನ್ ಕೇಸ್ ಆಫ್ ದ ವೈಟ್ ಲೈಟ್ ಇಫ್ ಕ್ಯಾನ್ ಟೇಕ್. ಬಟ್ ಇನ್ ಕೇಸ್ ಆಫ್ ದ monochromatic light what ever the width we get it is same for all, for dark and bright fringes ಎರಡಕ್ಕೂ ಸಹಿತ ಸೇಮ್ ಇರುತ್ತೆ. So in case of the diffraction, so the diffraction fringes we know that it is always unequal. So ಅದು ಯಾವಾಗ ಸಹಿತ unequal ಇರುತ್ತೆ like this. So we get the result. So we can observe whatever the width we get, so these are what unequal. So equal ಆಗಿ ಇರೋದಿಲ್ಲ ಅಂತ. Okay, so in case of the next point, so in case of this interference pattern, the bright fringes are same intensity. So ನಮಗೆ ಬ್ರೈಟ್ ಮತ್ತೆ ಡಾರ್ಕ್, ಸೊ ಇಟ್ ಇಸ್ ಅ ವಾಟ್ ಬ್ರೈಟ್ ಡಾರ್ಕ್ bright dark, again bright dark, so bright dark, again bright dark. Like this the interference patterns we get. So the bright fringes are same intensity. Bright fringes are what? This is a bright, it is a what? Bright fringes are same intensity, and intensity of the dark is generally what? A zero. Intensity of the dark is zero, or there is a small value. So intensity tumba kammi irutte athwa zero irutte in case of the interference. But in case of the diffraction patterns, what happens? So all the bright fringes are not same. All the bright fringes are what? Not same. And here means the intensity is not same, and the intensity of the minima is never zero. Intensity of the minima is never zero. So idu maximum. So central maximum anta karite. It is what? Minimus. Those intensity is never zero. Andre zero ಆಗಿರುವುದಿಲ್ಲ ಅಂತ. Okay. So again we are seeing the conditions for minimum and maximum in case of the interference and in case of the diffraction. ಎರಡು ಕೇಸಲ್ಲೂ ಸಹಿತ ನಾವು ಕಂಡೀಷನ್ ನೋಡಿದ್ವಿ. ಯಾವುದಕ್ಕೆ? ಸೊ ಮ್ಯಾಕ್ಸಿಮಾ ಯಾವಾಗ ಪ್ರೊಡ್ಯೂಸ್ ಆಗುತ್ತೆ, ಮಿನಿಮಾ ಯಾವಾಗ ಪ್ರೊಡ್ಯೂಸ್ ಆಗುತ್ತೆ, ಅಥವಾ ಮ್ಯಾಕ್ಸಿಮಾ ನಮಗೆ ಸಿಗಬೇಕಂದ್ರೆ ಏನು ಕಂಡೀಷನ್ ಇರಬೇಕು, ಪಾತ್ ಡಿಫ್ರೆನ್ಸ್ ಎಷ್ಟಿರಬೇಕು, ಫೇಸ್ ಡಿಫ್ರೆನ್ಸ್ ಎಷ್ಟಿರಬೇಕು, ಎರಡು ವೇವ್ ಮಧ್ಯೆ, ಎರಡು ಲೈಟ್ ವೇವ್ಸ್ ಮಧ್ಯೆ. ಸೊ ಫಾರ್ ದೋಸ್ ಸಿ ಇನ್ ಕೇಸ್ ಆಫ್ ದ ಕಂಡೀಷನ್ಸ್ ಫಾರ್ ಮಿನಿಮಮ್, ಯಾವುದರಲ್ಲಿ ಇಂಟರ್ಫರೆನ್ಸ್ ಅಲ್ಲಿ ಕಂಡೀಷನ್ಸ್ ಫಾರ್ ಮಿನಿಮಮ್, conditions for minima. So ಏನು ಕಂಡೀಷನ್ ಇರಬೇಕು? ಪಾತ್ ಡಿಫರೆನ್ಸ್ ಫಾರ್ ಮಿನಿಮಾ. ವಿ ಆರ್ ಸೇಯಿಂಗ್ ಅಬೌಟ್ ದ ಮಿನಿಮಾ. ಪಾತ್ ಡಿಫರೆನ್ಸ್ ಎಷ್ಟಿರಬೇಕು? ಇಟ್ ಈಸ್ n+1/2 ಲ್ಯಾಂಬ್ಡಾ ಇರಬೇಕು. ಸೊ ದ ಪಾತ್ ಡಿಫರೆನ್ಸ್ ಈಸ್ an integral multiple of odd. Okay, integral odd multiple of what? Lambda ಇರಬೇಕು. So and the phase difference ಎಷ್ಟಿರಬೇಕು? ದಟ್ ಈಸ್ ಪೈ is equal to n+1/2 what? 2 pi. In terms of 2 pi ಇರಬೇಕು. You can say n is equal to 0, 1, 2, 3 so on. Okay. So if you can say here, if n is equal to 0, 1/2 lambda means part difference is lambda by 2. We get the what? Minima. So we can say what? The path difference is in terms of what? Lambda by 2 means we get the what? Minima. And phase difference, if n is equal to 0, 1/2, 2 pi means 2 gets cancelled, pi. So in terms of pi, 2 pi. Suppose if n is equal to what? N is equal to 1 we are given means 3/2 means the phase difference is in terms of pi, 3 pi and 5 pi. Like this means whatever the thing we get, add multiple of pi we get. And if n is equal to 0, 1/2 lambda, n is equal to 1, 3/2 lambda. So n is equal to 2, 5/2 lambda. Like this we get. So in the same way, for these condition for minima in case of the diffraction pattern is what? Delta is equal to what? N lambda means the integral multiple of lambda. That is what? Delta indicates a path difference and phase difference. Phase difference pi is equal to 2n pi means the what? Even multiple of what? Pi ಇರಬೇಕು. ಯಾವುದರಲ್ಲಿ? ಡಿಫ್ರಾಕ್ಷನ್, just opposite to the what? Interference. So we know that in case of the, just remember the conditions for maxima. So minima ಗೆ n+1/2 lambda, maximum ಗೆ so path difference that is delta is equal to what? N lambda, and phase difference pi is equal to 2n pi. So we can say n is equal to 0, 1, 2, 3. Observe carefully. ಯಾವುದು? ಮಿನಿಮಾಗೆ n+1/2 lambda, pi is equal to n+1/2 2 pi. Maximaಗೆ delta is equal to n lambda and pi is equal to 2n pi. Just for the diffraction it is opposite. So for the diffraction, the conditions for the minima is what? The path difference is delta is equal to n lambda, and phase difference is pi is equal to 2n pi. And for the maxima, so we can say the path difference is equal to what? N plus 1 by 2 lambda, and phase difference pi is equal to what? N plus 1 by 2 pi, where n is equal to 0, 1, 2, 3, so on. So these are the difference between the interference and diffraction. Now in the next class we can go for the resolution of the images.